Hello, in this video we're going to be applying hypothesis testing to our normal distribution. So these are the steps required to apply hypothesis testing to the normal distribution. I'm going to read them out, but obviously I'm going to do an example straight after to show how they work. So the first step is just to write down your normal distribution, and then the second step, we need to convert this into a slightly different normal distribution based on the sample size. So we divide the variance by the sample size to find the variance of the sample, and rather than referring to it as x, we now call it x bar. We then find the probability that x bar is less than or greater than the measured value, as we normally do. We compare that with the significance level, as we normally do, and we decide if it's significant or not, and whether to accept or reject H0, and conclude our answer based on sufficient or insufficient evidence. So here is our example. The lengths of speeches at the party conference are modelled by a normal distribution with a mean of 78.4 minutes and a standard deviation of 14 minutes. As a result of Brexit and COVID, it is predicted that the mean lengths of speeches may increase. A random sample of 49 speeches is selected. The mean length of this sample was found to be 81.9 minutes. Stating your hypotheses clearly, test at the 5% level whether there is evidence of an increase in the length of speeches at the party conference. So quite a long question, let's break it down. So write down the normal distribution. Well, the mean is 78.4 minutes, the standard deviation is 14, so x is normally distributed with a mean of 78.4 and a variance of 14 squared. And we've also been told that the sample size is 49, so n, little n, equals 49. We've been asked to state our hypotheses clearly. So our null hypothesis will be that the mean is still 78.4. Our alternative hypothesis will be that the mean has now increased, as it says in the question, so it's now greater than 78.4. So our second step says to divide the variance by the sample size to find the variance of the sample. And this is now x bar. So you'll notice that I've rewritten it with x bar instead. The mean is still 78.4, but the variance is 14 squared divided by 49. 14 squared is 196, divide that by 49, and we get 4. So the variance, the new variance, is 4, and the new standard deviation is 2. For the third step, we've got to find the probability that x bar is less than or greater than the measured value. Okay, so we're talking about increase, so we want to find the probability that x bar is greater than this measured value of 81.9 minutes. As usual, we get our calculator up, we go for menu 7.2. The lower is 81.9, the upper is 9,999 if you want. The standard deviation is 2, and the mean is 78.4. And then after having pressed equals twice, after entering 78.4, we find the probability that x bar is greater than 81.9 is 0.0401. Now our conclusion will of course depend on what the significance level is. We've been asked to test at the 5% level, okay, and 0.0401, i.e. 4.01%, is obviously less than 5%. When we compare our probability with the significance level we've been given, okay, if it's less than the significance level, then that implies that it is significant. So in this particular case, because 4.01% is less than 5%, that tells us that our result is significant. When a result is significant, that means that we reject H0. Our null hypothesis has been proven or suggested to be incorrect. So that means that we can write the statement that there is sufficient evidence of an increase in the length of speeches at the party conference. I'm just going to show you an alternative method to deduce the same result using critical regions. So we start in the same way. We've still got the same hypotheses, we've still got the same normal distribution, which we convert into a new one by dividing by the sample of 49. So we've still got x bar is normally distributed with 78.4 for the mean and 2 squared for the variance. But then what we do, rather than work out a probability and compare it with 5%, we work out a value that would correspond to 5%. So what value of A is there such that the probability that x bar is greater than A is equal to 0.05. So because we're doing it this way, that means we can use menu 7.3 with the inverse normal. We are looking for the area to be 0.05 above A, and don't forget the way the calculator is set up, it's for less than, so we're going to use an area of 0.95 with our standard deviation of 2 and our mean of 78.4. So typing that on the calculator, pressing equals twice, we get a value for A, the critical value of 81.69, which means that the critical region is greater than 81.69. Now our measurement was 81.9 minutes, so when we compare that, we find out that it's in the critical region because it's greater than 81.69, and hence that also tells us that our result is significant. So we're still going to reject H0 and state that there is some evidence that the length of speeches may have increased.